Hello everyone, myself RAJORSI SINHARAY from third year ECE department at Coochbehar Government Engineering College. So here I am going to present our assignment topic, which is operation of MOSFET, which is under the subject of CMOS VLSI design. So let's see. First of all, we are going to see about the structure of MOSFET. The name MOSFET is derived from physical structure metal oxide field effect transistor, as we all know that MOSFET is a field effect transistor. A NMOS has doped source and drain on p-type silicon substrate. A gate electrode is placed above, electrically insulated from the silicon surface. The conventional gate material is heavily doped polycrystalline silicon. The gate is usually doped the same type as the source or drain. That is, the gate and substrate are of two opposite types. The conventional gate insulator material is silicon dioxide. That's why the name came metal oxides. So the body terminal is usually connected to fixed potential to minimize current flow between substrate and the source or drain regions. So here we're going to see about why MOSFET is preferred over BJT. That is, why a field effect transistor called MOSFET is preferred over bipolar junction transistor. MOSFET is a voltage controlled device, while BJT is a current controlled. MOSFET requires negligible input current, reducing power consumption. MOSFET has very high input impedance. MOSFET provides faster switching speed. MOSFET generates less heat and power loss. MOSFET is more efficient in digital and power circuits. MOSFET is easier to integrate the ICs. MOSFET occupies less chip area. MOSFET is more reliable and stable. Hence, MOSFET is used in modern electronics, processors, and power devices. Now, what are the working principle of MOSFET? When a voltage is applied at the gate, it generates an electric field across the oxide layer. These electric field pushes and attracts charge carriers inside the semiconductor. A thin conductive channel is created between the source and drain. This channel allows current to flow from drain to source. When the gate voltage is reduced or removed, the electric field vanishes and the channel disappears, and subsequently current stops flowing there. Now, what are the mode of operations in MOSFET? A MOSFET works by controlling the flow of charge carriers between the drain and source using the voltage applied at the gate. Structure in off condition. The MOSFET has heavily doped in regions, source and drain, placed in a placed in a p-type substrate. The gate is placed above the substrate and is insulated by an oxide layer, that is the silicon dioxide oxide layer. When no voltage is applied at the gate, there is no conducting path between drain and source, therefore no current flows. Now we'll see about the condition when gate voltage is applied. When a positive voltage is applied at the gate, it creates an electric field. These electric field repels holes in the p substrate and attracts electrons. As more electrons gather under the gate, the thin layer of electron forms. This layer is called the inversion layer or channel inversion layer. When gate voltage is reduced, then what will happen? If gate voltage is reduced below Vt, the threshold voltage, the electric field weakens, the channel disappears and current flow stops. Now if voltage is applied between drain and source, electron flow from source to drain. Conventional current flows from drain to source. The formation of channel. When gate voltage becomes greater than threshold voltage, then what will happen? The electron concentration becomes high. A continuous conducting channel is formed between source and drain. The channel allows current to flow. So now let's see about the regions of operation for MOSFET. When the gate to source voltage, that is VGS, is less than the threshold voltage VT, the MOSFET operates in the cutoff region. In this condition, the electric field produced by gate is not strong enough to attract charge carriers and form a conducting channel between the source and drain. Therefore, no current flows from the device and MOSFET behaves like an open switch. The region is used when the MOSFET is required to be off, to be in the off state. When the gate to source voltage becomes greater than threshold voltage and drain to source voltage is small, the MOSFET enters the triode or linear region. In this region, a conducting channel is fully formed between drain and source. The drain current increases almost linearly with VDS. This is the drain to source voltage, meaning the MOSFET behaves like a voltage controlled resistor. These region is mainly used in analog circuits and switching applications where controlled current flow is needed. As the drain to source voltage is increased further while VGS remains greater than VT, the MOSFET enters at the saturation region. In this region, the channel near the drain gets pinched off. The condition, it's a special condition. So here the channel near the drain gets pinched off, but current continues to flow due to the VGS. Because of this property, the MOSFET behaves like a constant current device and is widely used for amplification. Thus, by varying the gate and drain voltage, a MOSFET can be made to operate as an off switch or cutoff, a variable resistor, triode, or an amplifier saturation, making it a highly versatile electronic device. So now we are going to see how a MOSFET work as a switch. So the topic is MOSFET as a switch. A MOSFET is widely used as an electronic switch because its on and off state are controlled by gate to source voltage VGS. When the gate voltage is less than threshold voltage, that is VT, no conducting current exists between drain and source. So the MOSFET remains in the cutoff region and behaves like a open switch. In this condition, no current flows through the device. When the gate voltage is increased such that VGS is greater than VT, just greater than the threshold voltage, a conducting channel is formed, allowing current to flow between the drain and source. The MOSFET now operates in an on state, behaving like a closed switch with very low resistance. Because the gate is insulated, only a small control voltage is needed to switch the large currents, making MOSFETs extremely efficient. Due to this first and low power switching capability, MOSFETs are extensively used in microcontrollers, power supplies, motor drivers, digital ICs, and switching regulators. So these by that procedure, MOSFET work as a switch. Why MOSFET is ideal as a switch? Now see, needs only voltage, not current at the gate can switch. Large current using small control signals generates very little heat, can switch thousands of times per second. So by this we have seen how does a MOSFET work. So now see advantages of MOSFET. A MOSFET, it is associated with very high input impedance and it draws negligible input current. A voltage control device, making it easy to drive low power consumption, ideal for battery powered system. High switching speed, suitable for high frequency applications. Low on-state resistance, reducing power loss. Less heat generation, improving efficiency. High reliability and long life. Small size, allowing high density IC fabrication, easy to integrate into microchips, widely used in digital analog and power electronics. So by this we have reached at the point to conclude whatever we have studied throughout our presentation, whatever we have seen throughout our presentation. We have seen about something for MOSFET. So the MOSFET operates by controlling current flow between drain and source through the gate voltage. Its ability to function in different operating regions makes it highly effective for switching and amplification. Due to low power consumption, high input impedance, and fast response, MOSFETs are fundamental components in modern electronic circuits. So, thank you everyone.